Hi everybody, welcome back. Wow, seeing how it went from summer to winter really fast, what it is that I am taking a slight diversion and I'm going to be going in between the Sport Quattro and this. And I got to put this motor in because I got to use the engine crane downstairs to get the motor out of the Sport. So what I need to do first is we need to go in here and I'm going to show you all of the CIS system that's in this car from Renault. And you'll probably take a look at it and go, there's an awful lot of stuff in there, and that's the reason why I'm pulling it all apart. And that's, you know, I mean, besides it not working, it's just like I hate that stuff. It's not, you know, I can't wait to have something that's actually programmable. I am like so ecstatic. But other than that, let me first bring you in here, and I'm going to show you all the stuff that I'm going to remove. Then remove that, and then I'm going to dump this lump inside the R5. And pretty much get this thing start going, you know? I'm not sure if we're going to get it running, but at least we'll get a good chunk of it done. All right, yeah, let's just go over here and I'll show you what's going on. Here's the left-hand side or driver's side of the car. What do we have here? Well, this right here is the air meter plate. What it does is, no, I can't get a hold of that nut. Usually you have to use a magnet. But what it does is air gets sucked into the motor. This lifts, and it lifts a piston that's on the fuel distributor, which feeds all of the injector lines, like right here. What it does is that this flapper plate controls, it's basically the mixture indicator, what it is. What controls the actual mixture is this. This is the control pressure regulator. This controls the amount of pressure that's put on the top of the fuel distributor. So the piston that's pushing down on this flapper plate only goes, you know, only has so much pressure on it, which will set the actual mixture of the car. What it is that this control pressure regulator will basically, it's like 25 to anywhere between 25 to 33 psi, I think, is cold. What happens is when you start the car cold, it basically runs at 33 psi, which is rich. Then the two heating elements inside this control pressure regulator heat up, expand, and bring the pressure up to like 50, 55 psi. This one was 54 psi because that's what this system was. And what it was is that this thing was screwing up because after a little while, it would go to 75 to 77 psi, almost 80 psi, which is what they call full control pressure. That's what you test fuel pumps at. To see if the fuel pump is good enough, you generally test on a CIS system, you know, full pressure from the fuel pump, which is supposed to be like, you know, 75, 80 pounds, roughly, depending on the day. But what it does is that when this thing controls the pressure to that piston, and this is what I set up. If you guys want to know an easy way of setting things up to monitor this, right here, as you can see, this is a double banjo bolt. This was on a 929RR brake system. You know, I think it was like one caliper and then the other caliper or whatever. But what it is that you use a double banjo bolt, and I just use that double banjo bolt, the brake line, and a gauge that goes up to 100 psi. So you can see it. It goes up to 30 psi roughly at cold. Then you see it goes up to 55 and stays there, and it runs really nice. And then, no matter how many times I cleaned the pressure regulator and did all this, it always went up to like 77 psi. So the pressure regulator was actually bad. All right, well, I'm not going to mess around with it anymore. And that's the reason why I'm doing this. Plus, we have a ton of failure points on this system. And you're probably saying, well, what do you mean by failure points? Failure points is a possibility of gas leaking. These lines, that's a single failure point because it's 40 plus years old. Anything on this line can basically burst. Anything on this line can basically burst. Also, every single banjo bolt has two crush washers or two sealing rings. Each one of those sealing rings is a potential point of failure. They can crack and they can leak leak fuel or blow fuel out just because they're old. Now, that's an awful lot of points of contact of failure. You can tell by all the lines. Now, we have, also, when you guys are trying to pull the injectors out of your car, this right here is a little clip that's on like that. You have to pull this off. This goes around the intake manifold little cup, and it just goes like this. But in order to get the injector out, you pull this out and then the injector will slip right out. Other than that, you try and pull them out with this clip on there, you're going to break the injector. So just be careful of that. It also the I almost forgot to say, this right here is a cold start injector and also a hot pulse injector. Sometimes, like with the Audis, they use these as a hot pulse because when the engine gets so hot, they need just a little bit extra fuel to start it. So that was it. All right, back into this, we have two fuel pumps here, each one being fed by the individual fuel tanks underneath the seats. There's two of them. Also, we have a main fuel pump right here. These two fuel pumps feed this right here as a surge tank. It fills the surge tank. It goes down into this fuel pump. It goes into this right here, which is a fuel accumulator, which accumulates fuel and maintains a constant pressure to the actual system. Goes through the fuel filter into the fuel distributor. From the end of this fuel pump, I'm going to remove all of it because I don't think I'm going to need a fuel accumulator, and I want to use a different filter because I might be deadheading the system on the EFI. Don't know yet, but the first things first, I need to pull this housing assembly off of the fuel distributor. Also, it's kind of funny, this housing right here on the bottom part of it, the filter that it uses is the same thing as a Volkswagen Rabbit. So, I think I have another plastic one kicking around that I might be able to turn into the air intake tube for the turbo, but I don't know yet because I haven't found it. But first things first, let me get some tools, and I'm going to start pulling all of this stuff off so we can get this out of the way so we can get the motor in there. Hi, everybody. As the sign says, yes, it's been about 6 months. Tell by the coat. Oh, yeah. It's been a whirlwind, between, because I said at the beginning of the video I was going to be in between this and the Sport Quattro, but the Sport Quattro just took so much time. And then the Rally Quattro took so much time. And then I had to get the tractors done in order to, as you saw when I painted the bottoms of the cars, I had to get the tractors done and have those forks on it in order to get the cars out so I can spray them, the bottom of them. It's not a show finished job, finished job, whatever, or a show quality job, but it's just, getting it on there so it don't rust. But it's like anything. You have to take priorities in your project. Whether you're doing a house or a car or motorcycle, whatever it is, you're going to have to do priorities. And this was not the biggest priority because the other ones were temperature sensitive, and I wanted to get further along on those. This is just sheer fun. That's all it is, just for sheer fun, and I needed to get those things done because that was the worst to do. They were not fun. But what I've done, prior, since you've seen the last video, is I put this panel in, I put all the bolts in, for the mounts in the back and stuff like that. But what are we going to do this video? Well, we have to get the fuel system to feed fuel to the actual throttle bodies. We have to set up all the sensors in the car. So we have them there. We have known positions of where we're going to build our harness to. We also have to have the exhaust, not done, but pretty much in mock-up stage of exactly where the O2 sensor is going to be. We also have to get fresh, clean air to the turbocharger. So we've got to build the top plate. It's all the small stuff that you need to put together, and then the final thing is you build the harness to where you're going to put the ECU and how you're going to do it. So that's the, that's the $1,000,000 question is after everything's there, okay, then we can build towards that. Now, what I'm going to do first is show you how nice the ducting is for the intercooler. Talk about, I mean, it's much better to be lucky than good. So I'm going to bring you over, show the ducting, then I'm going to pull the intercooler off, pull the ducting off, and then we're going to figure out where we're going to do we're going to start with the fuel system. We need the fuel pressure regulator, and we need a fuel filter in this thing, and it's one and the same, and I'll show you what I got. All right, let's run over. Let me show you what the intercooler looks like with the ducting, and yeah, we'll just get to it. Here, what do you think? This is the stock. I haven't modified this at all. I mean, it's in there right now. The nut that holds the top in like this, that would be tight. That's just finger tight. As you can see, take a look right here and right here. And you can't see it down there because I can barely see it. It's all equal all the way around. So this is exactly where the original intercooler was, because this is how much gap that I had. So I'm pretty happy that this worked out with the measurements that I did. I'm pretty ecstatic about that. These things, the little bars that I put on here just to tighten it in, well, they're not going to work because this one hits this right here, this part of the ducting. This one hits the top plate right here for the top cover. So, I mean, but I knew I was going to have to do that. I knew I was going to have to redo these things in the back of my mind because, that's why I just threw these on there temporarily. And this is what you're going to do. You're going to find it. You're going to just throw things on there temporarily saying, I'm probably going to have to redo that. It's like, yep. In the back of my mind, yes, that's what it is. All right. What I'm going to do is I'm going to pull this or push this ducting back, pull the intercooler off, and then we're going to figure, I'll show you what I have for a fuel filter and a fuel pressure regulator all in one unit and figure out where we're going to put it here. All right, time to reveal it. Remember I said a long time ago when we were doing this injection system that it's a deadhead system. Basically, there's no return pressure regulator in this system. It just has feed absolute pressure to the fuel rail, and the return was somewhere else. It's sort of like almost like the 914 and Alfetta pumps that had a return line in them. Or it's like, how can I put this? The LSs, I guess, are deadhead systems. And I found out, I remember watching this old video. This a guy named Al from the Skid Factory, and he was saying that they used to use BMW fuel filters that had their own pressure regulator. And I said, boy, that would solve an awful lot of problems. So, of course, click, trying to get on the computer, trying to figure out, all right, what is it? And I kept looking, couldn't find it. So I was just like, all right, well, so I kept putting in different things, and then it came up. And what it is this. This filter right here, I believe it was from 2003 to 2006 BMW 3 Series. I'm looking at this going, all right, what problem does this solve? Well, it has the control pressure regulator right here. That's a big thing. It's supposed to give 50 PSI at this port right there. Then it has an inlet and a return line that goes back to the system. So when the fuel pump runs, it doesn't overpressure and it goes back to the system using this control pressure regulator. Big thing is, I was thinking about using an external pressure regulator in this and running a hose back through the end of the fuel rail and all. You know what? That's more complication than I completely want. This is not for a 1,000 horsepower car. This is for a 200 horsepower car or 220 horsepower car, whatever it turns out to be. But the big thing is that, we're going to have, two lines, one line coming in, one line going out. So that's 4 clamps from the fuel pump to here, and from here to the return tank is 4 clamps. And we got 1 clamp here and 1 clamp on that. That's only 6 points that could possibly fail besides the lines themselves. But I think this is it. And what this also does is increases the capacity of cleaning the fuel. The original fuel filter in these things are about this big. So probably about 2/3 the size, maybe, actually maybe a little over a half, a little under a half. But it's, you get 2 point something more times of volume cleaned in this filter. So that's a kind of a win. less amount of hoses, less amount of everything. I consider that a win. But let me first go over here. I gotta get a better light so we can figure out where we're gonna put this in the car, so we can get at it and change it when we need to, just in case the fuel pressure regulator acts up, or we just need to change the fuel filter. Yeah, one of the things. And plus, on Amazon, $21. That's pretty cheap. At least I thought it was. Great for experiments. All right, let me go light this thing up and let me see where we can put it. One thing we have to do in order to start working on our fuel system is make access. The greatest thing about these Renaults is that you can have access. These are the grills that go in here. There's 2 tabs on the back that fit into 2 tabs right here, and there's 2 speed nuts right there, which you just have, standard screws like this. Phillips head screws goes in there. I've already taken these off. This right now gives us complete access to everything in here. We can sit and look and figure out, okay, we can put our arms inside there. Also, what we have is this, the rear window. What we have is it swings open like this. It's locked in with this right here, with this pin. Goes in like that, locks it in, it's great. And we have another access. Let me show you again. This is the greatest thing about this Renault. All right, these are the last 2 access holes that you can have, or you have on the R5 Turbo that just makes life a heck of a lot easier. What Renault did was they put access holes here so you can get at the water pump, you can get at the alternator, and you can get at it real fast. Now, what the good thing is that, seeing how I did all of this stuff, I can easily get at the throttle bodies or the injectors or the fuel line right here. And where I put the crank position sensor, I can easily get at it from the center one. And this is the reason why I built this way. Also, if you ever need to have like an access hole or something like that in a flat panel going into something, one thing I learned from Renault, which is kind of interesting, is this was all just a flat piece of metal right here, but what they did to increase stiffness was they made a lip all the way around it. It's almost like a ceiling lip, but I'm sitting there going, geez, that was a very good idea, because they increased the panel stiffness by having this all over there instead of just having a flat wobbly piece of metal right there. I mean, they would have put indentations in there if they needed it, but they instead chose to use a removable panel, which I think is fantastic. And then the panel that goes on here is steel and heavily insulated, and it has basically a heat barrier on the other side to reflect the heat back into the engine and not into the cockpit for the crew, which I thought is awesome. So, without any further ado, let's just go into the engine bay. I'm going to put a light in, put the GoPro over there, and let me show you what I have to, what real estate we have down in that section, and what Renault did for their fuel system that we can try and tap into. Here we have the area that we need to have the fuel filter in, and what it is, this is where the original fuel distributor setup was in flapper plate. This is the filter right down here. We have the main fuel pump that goes to the fuel injectors. We have 2 fuel pumps. I'm not sure if I can see it over there. You can see it on the camera over there. There's 2 fuel pumps that are fed off of the fuel tanks that go into this right here, which is a surge tank. It goes into the top. This bottom line right here goes into the main fuel pump. After the fuel pump pressurizes the system, and it's all done with a fuel pressure regulator and all that stuff, the excess goes into a hole right here, which is kind of strange on this, because it's just not one line, it's 2 lines. One from right here is where the pressure accumulator is, and there's a line that goes off of that also into here, or it's fed off of it. It's really just a strange system that I see. But let me show you what it is over on the bench, because we have this fuel filter right here. This is the way it came out of the box for the BMW. And I'm looking around going, well, if I go right here, it's gonna block the turbo inlet pipe and all. If I go over here, well, how about we just put it in the original place that the fuel filter was at? And I'm looking at it going, you know what? Over here, we got plenty of room to have a high pressure line off of the CIS pump and just go right into this. And then the excess right here, or the out return line, is on top, and it's just going to make one bend up right into here. That's it. Now, you're going to take a look at I'm going to show you the diagram of the fuel system on this, and it's something I've never seen before, and it's about the fuel pressure accumulator. But let me bring you over to the bench. We have to move this rubber collar up, which is, I tried doing it, and there's only one way to do it, which I kind of figured out, and I want to show you just to make it easier on you. But I also want to show you the original return line system, because it's kind of it's something I've never seen before in a CIS system, but that doesn't mean other cars haven't done it, because, you know, I'm, you know, generally a Volkswagen Audi guy for the CIS stuff, you know, and the Porsche 911 and all these other stuff that I have that had CIS, but I've never seen this before, which doesn't mean other cars haven't used it. They probably have, but it's just something for me I haven't seen. All right, let me go bring this over to the bench. I'm going to show you how to slide this collar up. Really simple, and we can take a look at the fuel system and what they did for the return line, and how we're going to kind of, we're just going to kind of simplify it, because we're doing basically a simplified system on this thing anyway. And then I'll show you the fuel lines that go down to this. Here's a system right here. This is it all set up, and I kind of led you astray. Even though the brackets are pretty much exactly the same, the fuel, when I said it was the fuel filter bracket we're going to use, no, we're going to use the fuel pressure accumulator bracket, not the fuel filter bracket. Now, this is the original fuel filter, or original OEM, what I got with the car, and this is the BMW one. As you can see, virtually the same size in actual diameter right here, but this is about 2.5 times longer. So we're going to increase our fuel filtering capability. So, hey, I'm running with it. But what it is you can see right here, this is where the fuel goes in or goes out into the fuel filter, and this goes from the fuel pump into the accumulator, pressurizes it. This right here is a return line that goes into this off the side of the fuel distributor. This goes back into the surge tank. Here's a diagram from the factory. This is the factory parts manual. I'm going to put this up, but as you can see, it goes from the fuel pump. It loops around into the fuel accumulator, out into the fuel filter, then from the fuel filter into the fuel distributor. So this Y right here, off the back of the fuel accumulator, there's, all I can say is just residual fuel pushes into it that goes into this, and from the side of the fuel distributor, the return line also goes up inside there. This is what we're looking at. This is where the fuel return line is. This is that funky Y that's on the parts diagram that goes into that plug, and you're looking at it, it looks like 1/4-inch line. And this right here, I broke off. I had to cut this because I didn't want to break this fitting right here. I cut this line because it's hard as a rock that goes into this section right here. So let's, first things first, I want to move, see, this thing is rubber and doesn't want to move at all. So let me show you how I'm going to move this up to about right here. We're going to bolt it in, and I'm going to show you the fuel lines that I'm going to use for doing the system. This right here is a handy dandy heat gun. And all we have to do is heat this collar up. It's that simple. Let me show you. Right there should be good. When it cools down, it's got to basically lock itself on. But that's the easy way to do it, because I sat there and struggled trying to push this thing up. I said, what am I going to do? Oh, I don't want to cut it. I don't want to do that, you know. I said, let me try heat gun, and it worked. So, you know what? Better to be lucky than good. Let's throw this in there and lock it down. Let's see what we got. Let me show you. Actually, let me show you what I got for lines first. Here's a fuel line that I picked to do this application, because it's actually, the bends in it look really, really neat. And I think it's gonna really look cool. But you're probably wondering, okay, well, where did you get it? Well, I really didn't know, because it's in a box of fuel lines that I have, because I take all the fuel lines off of cars just in case I need something like this. I put them in a box and say, okay, all right, well, I need it for this. All right, we're going to do that, and blah, blah, blah. And, you know, it gives me something that I can use to mock something up with. So the lucky thing is I had a part number on it. So to tell you where I got it, I looked up the part number, and what it was This part number, 1JO130295B, doesn't really come up because it's superseded by another number from a 2024 Jetta. But they said previous cars this thing fit was a 1.9 liter Jetta, which was a diesel. And I'm looking at it going, geez, diesel lines. Diesel lines don't require a lot of pressure. And I'm kind of worried about that. But why did they put a quick connect clamp on here? Because that usually denotes fuel injection, you know? And I'm looking at it going, well, they only have compression clamps here, but I've used compression clamps on other things, but it's never for real fuel injection. You know, these things right here, these compression clamps, I've never used them for fuel injection. I've only used like Jubilee clamps on them or worm drive. And would these lines be strong enough to handle fuel injection pressure at 50 psi? Or you need to have at least a burst pressure of 75 psi, you know, because if it goes up that high. So I'm looking around going, all right, well, there's nothing on the line that tells me what the burst pressure is, because usually there is. If it's a carburetor line, I'll tell you have a burst pressure of like 15 psi or something like that. I don't know. I don't deal with carbs, but I just know if you put a carburetor fuel pressure line on it, on a fuel injection system, on a high pressure fuel injection system, it'll just blow. And a lot of people had a lot of problems back when the conversion from carburetors to fuel injection systems happened. You know, old mechanics would just put a standard fuel line in and blow and burn the car down. So we don't want that. I looked around saying, okay, well, next thing is I will look at it and say, what's the internal structure look like? Well, the internal structure is like this. It has a bunch of webbing inside there. And I said, okay, well, I've seen that webbing before. It looks like a high pressure fuel injection line. So I went and grabbed a fuel rail. This is from a Corrado G60. And I looked at it going, well, it looks exactly the same as this. So I looked on like Jim Ellis Volkswagen to find out how much this line would cost. Well, this line is like $300. So it's got to be high pressure. That's what I'm hoping. So this is what I'm going to use to mock up the fuel filter into the fuel rail. I think it's going to work fairly well by the way the bends are in this. Now, when I test the system, I'm going to test the system at full pressure to see if any of this line expands. That means if it expands, it means the webbing or the jacket or whatever you want to call the nylon inside here, the reinforcement, is not strong enough to hold the line together. It'll expand, and there's a good chance it'll rupture, so I'll just change the line. That's it. But this will be good for at least mock-up. I can get things going and seeing how everything is going to go. And if I need to replace the lines, I'll replace the lines. I got to replace a bunch of lines in there anyway because they're rock hard. But I won't do it until I get everything. Okay, this is exactly where I want it. Now I can replace them. Okay, what I want to do, I want to throw this in there, lock it down. I want to put this on there, and I want to set it up to this. This came off the fuel rail. I'm just going to cut the line because all it is just, what is that, PTFE line or whatever they call it. Just cut it so I can use the fitting, and I'll clamp down the fitting with a worm, or not a worm drive clip, but a Subaru fuel injection clip, basically. You know, a compression clamp, or not a compression clamp, a Jubilee clamp, if you want to call it. But the way Subaru does it with a bolt, and we'll just do it that way. And both sides will be just like that. You know, it's worked before in the past. Hopefully it'll work again. So let me bring this in. Let me bolt this in, and then I am going to put this on this on this, and then onto the fuel rail. Once that's done, everything else is pretty much simple, as in from where the fuel pump goes in and this comes out, because we are eliminating this line right here. All we're going to have is a barb and just a straight line that goes up into it. You know, we're just going to have one barb here. Well, we're not going to use this, but we have one barb on one side, one barb on the other. The line that comes out of here bolts onto the barb, bolts into the top tank. Hope that wasn't too confusing. But, all right, let's just zip over there. This right here is the original bolt. I don't know where the nut is. Well, it's a standard like M5 nut. And what you do is you put it in here and it compresses it down. This is going to be a little too short as in the amount of threads in there. Also, you have to have a I think it's a 4mm hex key on one side and a 6mm nut on the other. I think that's what it is, but I can't remember. But what it is that you know what? I can get one hand in here, but getting two hands in here, it really stinks. And having it, you know, it's one thing like with this, that's a 10mm, that's a 10mm. So, and this is an M6, this is an M5. And what it is, I want to make this a little easier for me to get at, because it's fine having one hand in here. It's another thing trying to put two hands in here. So, now that the fuel filter is roughly where I want it, what I want to do is I want to make it a little bit easier. This right here is a threaded speed nut. Probably pull it off a Volvo or a Ford or something like that, you know. Put it right there. Has an M5 thread to it. This right here is an interior screw. Probably, seeing how it's a Phillips head, it's probably from a Corrado. So we can go like this. And I can't turn it. There we go. Nice and stable. Doesn't move around. I can tighten it further, but just in case I need to move it around a little bit, I can easily loosen it up. All right, let me put the lines in. Let's see what we got for lines first. Here's the fitting that we have. And what it is that we have a 90-degree angle fitting off of this, off of the fuel rail. Here is the clamp. This is from a Subaru, and it's from a WRX. And here's the line that I'm going to use. This turn right here will go on to the filter because it's a 90-degree angle. We have to fit this right here. So I'm going to cut this right here, put the clamp on it, and then go from there. That way you can extend this thing down and it'll fit that filter. And it's just like, you know what? It's pretty cool. So, and I use these are like a Greenlee cutters. They're used for cutting cable, but they do a great job for cutting fuel line. There's that. Let's put the bottom one on. All right, the clamp is tight. If you're going to use a Subaru clamp, there's little metal plates inside here. It's like a dispersion plate. What it is you want to make sure they're underneath these lips right here of the clamp, so it gives a nice even compression to this line all the way around the fitting. I did the one on the bottom. I'm not going to do the lines from the fuel pump to the fuel filter or the return line because it's just straight line. That's it. I'll do it at the end, you know, because I'm going to order some new stuff for it. Because I don't think I have any that's long enough to do it. Also, what I got to do now, let's pull this line off. I got to bring this throttle body downstairs. I'm going to show you what I'm going to do to finish up the fuel system. We got to monitor what's going on. Let me bring this down. Let me show you that. Here we are at the bench, and we have to finish up the basics of the fuel system. We have the fuel pressure regulator in there. We have the fuel pump in there. The lines from the fuel pump to the filter, and from the filter return to the end point of the surge tank. That's pretty much easy, really straightforward, you know, not a problem. We have the line from the fuel filter to the fuel rail, and that feeds us our control pressure. One thing that we have to know about is what is our control pressure, because that's one of the things that I've learned a lot, especially with like the Cosworths and stuff like that, is it's critical that you know what the fuel pressure is, because the control pressure regulators on the Cosworths fail a lot. At least they have on me. I've had 2 fail. And that's a lot, you know, that's a lot compared to other ones, but I've also had the control pressure regulator fail on the R5 with the CIS system, and I think that's from just sitting around in the fuel that we have nowadays. But that's beside the point. What I need to do is I need to have a device or a sensor to actually measure the amount of fuel pressure in the thing, just so it doesn't run into a lean out condition. I can put hopefully something in the ECU that I bought that'll give it a limp mode so it won't burn up the motor. But all right, we're done with that. All right, here is the throttle bodies, from the Hayabusa that we have to put in. Now, I brought this down. This is ones from the Corrado that I showed you before. This is a standard Digifont system. As you can tell, power, ground, all it is they fire the injectors every single intake pulse, so you have 4 times the amount of fuel plus 3 going into it every single shot. Now, this right here, let's see if I can get a better shot. This is the intake for the fuel. This is the pressurized fuel going in. This right here is a control pressure regulator, and this is a return to the fuel tank. Now take a look at where they have the sensor. They have the sensor at the end of the fuel rail. Quite logical that Volkswagen did this, because here's the fuel, which I think is a fuel pressure sensor. That's what I thought it was. It's at the end of the fuel rail, and it's really, to me, that is, a very logical place to put it, because these 3 injectors are going to be using fuel. This position right here will be the least amount of pressure in the system if it started to go down at this injector right here. So if these things are higher pressure and this is the correct pressure, the only thing these things are doing is making the engine richer, not leaner. The lean condition in a forced induction application is really, really bad. You don't want to freaking burn a hole in a piston, and it's like in any engine, but it's just compounded when you get into forced induction. And this was a G60, which has that stupid G-ladder supercharger, which I think is just terrible. I just hated those things. But that's beside the point. Let me put this down. Now we have to figure out, we need to have a fuel pressure sensor somewhere in our system. Well, I'm looking at it going, oh, geez, I looked on eBay and Amazon and it's like, okay, what can I do? Well, I'll throw in one from the end of the fuel filter to the throttle bodies. So this is what I got. I got it off of Amazon, and you can take a look right here. It's just a barb fitting with a 1/8" NPT hole in it. And I'm sitting there going, okay, good. It's stainless steel, ought to work really well. Pretty tough. It's not going to blow off because it has nice barbs on it. And then I bought this as a fuel pressure sensor. This right here, standard jelly bean part. If you take a look at them, if anywhere from like $11 to like $22, they all look exactly the same. So they're probably all built in the same factory. So I looked at a lot of reviews. A lot of reviews said, yes, they're very accurate, but they do leak. And I'm sitting there going, okay, the leaking portion, if it's not through the top of it, it's usually because people don't put sealant tape on these things, or they don't do it correctly, and they generally leak. Plus, it's user error when it leaks generally, but we'll see what happens. I mean, these things are inexpensive enough, and they should be pretty accurate. Now, the fuel pressure that I should be running in the system is 50 pounds, is what people say. Maybe I'd say 40 to 50 pounds, okay? Now, if it runs like that, this sensor right here is 0 to 100 pounds. And I want, in like every sensor there is, whatever the sensor is the top reading and the bottom reading, because this is 0 to 100 PSI, in the middle is the most accurate, and that's what I wanted. Between 40 and 50 PSI, I want it to be the most accurate, and this thing should be. Now, I encountered a major problem with this sensor and this fitting. Now, I hope you don't run into this. You see the size of this. If you take a look and go like that, right here, if this thing, here, let me push this up. See that? If this thing is all the way in, which it shouldn't be, but just in case it's all the way in, if they didn't cut the threads correctly, this thing protrudes halfway in this 3/8 barb fitting. Now, you can get around that because it's restricting the flow, and you don't want restriction of flow into a turbocharged motor whatsoever. That's bad, because you'll create a lean situation and just blow up pistons. Now, you can, get this to be correct flow by putting this all the way in, tightening it all the way down, taking a drill and drilling all the way through. But when you pull this thing back out to clean up, all the edges and the burrs on the side, to give it a good flow into the actual sensor, there's no guarantee when it goes back in, it's going to go back in the exact way you want it. That's the problem. So what am I, that's a failure point right there. The second failure point, which is, because after looking at this, is that most people have their pressure sensor on the furthest away from the pump, basically, because they want to know that should be the lowest pressure point there is. Because if you sit there, every single time you make a turn, somebody was saying you reduce flow by, what was it, 10% or 20% or something like that. I'm not really sure. I never took fluid dynamics in school or anything like that, so I'm just a hillbilly. I don't really know how to design a system. I just say, well, it looks logical. Hopefully it'll work. But this is kind of going to guarantee it, because I need to put it at the end of the fuel rail, because that's going to be where the lowest pressure point is. And we lucked out. This throttle body setup has a point right here. This is where the fuel comes in. This right here is just, there is a port that looks like they probably bolt onto something or clamp onto something to read the pressure. In this one, there was just a M6 screw with a sealing washer on it. That's it. So I got to put that 1/8" NPT sensor on this. And if you look, it's kind of the same diameter. So it won't work. If I try to drill it out and tap it, it'll just break. But what I need, not what I need, what I looked around to do was do an M6 to 1/8" NPT fitting. And they do make them, and they do make them out of stainless steel. And I says, okay, well, geez, maybe I'll just buy one of those. And then I was looking really close at the pictures. The hole that has to be drilled in there to allow it to come through is an extreme point of restriction. Now, do I think it'll give me the correct pressure with that small a hole? Because it's like anything. If you have a garden hose with a really, small hole at the end of it, your pressure's built up on one side but not on the other until it catches up. And the big thing is, will it be fast enough to catch up? And I don't think it will. I want the same hole that's in this or greater, which that is, so I can put this on. So what's our solution? Well, we're going to have to make a fitting to weld onto this. And what it is that I looked around going, I have no idea, how to, where to buy one of these. So I, said, okay, well, I'll just take a piece of stock, I'll put it in the lathe, turn it down, center hole it, thread it and all that stuff. And I'm sitting going, man, I'm way too lazy for that right now. It's way too cold. I mean, yeah, it's only about an hour to do, but it's just, that's what it is. So what I did was I have these little capsules or whatever. See that? These are all metal bushings, all different sizes. I've taken them out of machines, out of cars, out of everything. They're all like this, seatbelt bushings and all that stuff. So I dumped this thing out and I found this bushing right here. It's not the correct diameter, but we can make it the correct diameter by drilling out the center and tapping it, because it's really, really close. The main thing is, take a look at the size. We have a good, 3 or 4 millimeters we have where we can go up and down, to not bottom out. So that way, it's not going to bottom out on this. It'll basically compress all the way in. And you have to remember, NPT fittings, their sealing is from a compression on the side, not from a sealing ring. But this would give us the ability to put a sealing ring on if we wanted to. But we got to get it straight. Let's see, what was I going to do? Yeah, I think I'm going to go over to the drill press, because this is, let's see, where is it? I got a 1/8" NPT tap. It goes in, but just barely. So I have to kiss the sides of this thing just to barely open it up. Really, I'm going to do it slow, but just barely kiss the sides. Then put this in the drill press, because I wanted to get it as straight as I can possibly get it. Go down there, have the NPT fitting, and then we'll come back and I'll show you what I'm going to use. We're going to pull this apart, and I'll show you what I'm going to use to weld up this little fitting onto that, so it'll give us a fuel pressure gauge. Hopefully. It should work. It should work. In my mind, it should work. But all right, let's go over to the drill press. Let me show you the setup I have over there. I want to get this as straight as possible. What I did, this right here is a center punch. It's the exact diameter of this. So I put it in the drill press, ran it through to make sure I had a nice, even, straight bushing, because this one was done on a lathe. And when it's done on a lathe, you get your natural center points and all that stuff. I don't want the drill bit to go over to one side or over to the other. You can tell by the threads that I took off, it was just kissing the sides in order to get it. Now let's bring over the tap and let's see if we can tap this thing absolutely straight. There, it started. Now let's do it the rest of the way, the old style way. Here's the fitting that I cut. As you can see, I'm not sure if you can because I'm not looking at the back of the camera, but the threads don't go all the way down. How did I determine how far they went down? This is how I did it. This is, whether it's not, this is the correct way to do it or not, I don't know, but this is just the way I did it. I took my caliper, and these things right here on the back side of the caliper, you see this little bar right here. What this does measures depth. And I got the actual height or the full depth of this outpour or this nipple right here. And that's why I figured out how far to cut down. And I kept cutting threads and checking them until I went down. I don't think you can really see it, but I went down to exactly, this is where the end of the threads are. So when I put this in, about halfway down, the threads are sealing against the other threads on here. They're making full contact. What that tells me is that, NPT fittings seal through the external portion of the thread going against the fitting. So when I put Teflon tape down, I can screw this thing down and it should seal fairly well. As a backup plan, another reason why I put the threads all the way down is that I can, if this thing doesn't seal, I can screw it down and put a sealing washer in there. That's why I did this in the drill press, so I can make it as straight as possible. So the sealing washer would go around here and seal evenly. That's a big thing. Let's pull off the fuel rail, and then we can get that disassembled so I can weld this onto that fitting on the fuel rail. This right here is going to be one of your greatest tools to getting this throttle body stuff up. And actually, it's a great tool. What is it? It's an impact gun or an impact driver. This, let me show you, is from Kmart back in the 70s. I got this in an auction. Greatest thing. Take a look at this. You see this screw right there? Right there? That's all this was all wallered out because trying to pull it out with this is a snap-on screwdriver. I also have Facom and Beta and Mac and all this stuff. And I used every one to try and pull this off, and it was rounding it off. I used this, smacked it, came right off. There's a helpful tip that you can do to get rid of, to get these screws off, because I don't know what they do to put them in, but they put them in really tight. And, even this snap-on screwdriver fits absolutely perfect in the screw. That's the thing. It fits absolutely perfect. You would swear it would get it off, but it doesn't. So there we go. Use one of these things. These things are absolutely phenomenal. Take a look right here. You see the wetness in there? Right there? Use motor oil inside there to make it hit or make it spin freely. It makes a world of difference. So there's a quick little tip in this video to show you that, yeah, buy an old tool from Kmart, and oh my God, it works freaking awesome. It works better than the Mac one or a Snap-on one that I have. I don't know which one it is because I never use it. I use that one. All right, let's pull this fuel rail off and get this thing ready to weld up. Remember, before you weld up, pull off these fittings right here, these O-rings, because they will melt like crazy. if you can get on eBay also, these dental tools, you find them, great for pulling O-rings off. Absolutely fantastic. Now that we have this thing stripped, pretty much, we need to center this thing onto this. We can't have it, you know, off-centered or anything like that, because I don't want to restrict any flow whatsoever. And you're probably wondering, well, how are you going to do that? Well, in my bucket of bushings, I found this. It's probably from a computer, or probably, actually, I don't know, probably from an Audi or something like that. But what it is, it's just a big washer with a machine point on this, and it was used for something. I have an M6 bolt that's the correct length. Here is a threaded portion. Here's the non-threaded portion. This thing goes right in and centers right there. So what I want to do here is put this together. There you go. It's absolutely centered in on this rail. The fitting mount is centered exactly on the point of this rail, so we have full flow of that M6 threaded portion into this bushing or this thread adapter or fitting adapter. All right, now I'm going to clean this thing up, and then I am going to weld it with a TIG welder, because that's the only thing that will be precise enough to actually weld it. All right, let me get that set up. It's going to take a couple of minutes, and we'll come right back, and I will clean this up and make it work. This is done. What I did with the drill is, remember it was an M6, I just cleaned the threads out is what I did to make it a smooth bore. Access right into the pressure switch like this. What I have to do next is, well, what I was going to do is mess around with the throttle bodies and all that stuff, because I wanted to put this all back together again. But I'm not going to. While this thing was cooling, I went up and on the computer and I was trying to research these injectors to see what they were. Initially, I found out that, I guess, I'm not sure how true it is, but the Hayabusa injectors are 27-pound injectors, and I was just going to use that to start the car, then take them all apart and, you know, and redo it and get the real injectors. But I don't really know what injectors these are. I found the name of it. Was it Hyken or something like that? Well, I forgot what the name is. But I took the name of the injector, I put it in, and on the other side it says 1080 or 10B0. And there was a couple of numbers on a few of these injectors. Two of them didn't have anything. And was it this one? Or is it this one? This one had ABS right here with a looked like an 8 and a couple other numbers over here. I use my magnifying glass to look at this, and there's another one. I think, is this one that have it? Yeah, I think this is the one that had it. They had different numbers on here, so I went there, put them on the internet. I spent, you know, a while trying to find out what these injectors are from, because I mean, for the most part, those look like Hayabusa throttle bodies, and they're supposed to. I mean, I found the Hayabusa number that's supposed to be on here, but I couldn't find it on this. So, all right. What I have to do is I have to get a set of these injectors. Now that I know what they are, I can order them. And if you look at this, this right here is out of the Mega Manual for Mega Squirt, and I'll give you a rough indication of what you need for injector size for the horsepower you want. Well, max I want 250, pretty much. That's about as much as I want to safely run in the car. And it's a 4-cylinder, so I need 37-pound injectors or 389 cc per 300 cc per minute injectors. So I got to go up and find those. And seeing how I don't have them, I'm not going to put all this stuff back together. So this is going to sit on the bench. And what are we going to do? Let's run upstairs. We're going to start doing the airbox, because that's the next worst thing to do, or the next biggest thing to do. And after that is the exhaust and the heat shields. And yeah, so let's run up there and let's see what I have to make an airbox.